For lesson 12's homework, we're going to do, just again, finish up our work with density and volume. So a snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice, as shown in the diagram below. The inside diameter of both the cone and the hemisphere is 8.3 centimeters, and the height of the cone is 10.2 centimeters. The desired density of shaved ice is 0.697 grams per cubic centimeter, and the cost per kilogram of the ice is $3.83. Determine the cost it is to make 50 snow cones. So the first thing we want to do is we got to find the total volume, right? Because we see this, we see the word density, we know we need to be our D equals M over V. So I already see we're going to have to do a unit conversion because our density is in grams and then our cost is in kilograms. So our answer that we find from our formula is going to be in grams, and then we'll have to divide it by 1,000 to get our kilograms. But first things first, we have to find the volume of our cone and then the volume of our hemisphere. And we'll add them together to get our total volume for the ice. So cone 1/3 pi r squared h gives us 1/3 pi. So if we have a diameter of 8.3, we really have a radius of 4.15. So 4.15 squared times 10.2 is going to give us a volume of, now I could choose to keep this in terms of pi, but with all these decimals that are already in there, I'm probably going to have a pretty long decimal as it is, so I might as well just put everything into the calculator at the same time, and we'll follow our 4 decimal point rule. So 183.9606. So 183.9606, and then since it's 6.7, we'll go to 0.7. So our hemisphere now is 4/3 pi r cubed, and again, since it's a hemisphere, we're going to cut it in half. Now, same thing here. I'm just going to end up putting everything into the calculator because of all the decimals that are already in there. So 4/3 pi 4.15 cubed, and then times a half, since we only have a hemisphere, gives us 149.6935. So 149.6935. So now if we want a total, we're going to add those two together. So 183.9607 plus 149.6935 gives us a total volume of ice of 333.6542. Okay, so there's our total volume. So now we can plug that into our density formula. So 0.697 over 1 equals M over 33.6542 gives us a total mass in grams of 232.5570. So 232.5570. Now remember, that's in grams. So we now have to divide that by 1,000 to get ourselves into kilograms, which gives us 0.232557, and by this point we can kind of leave out that last 0, knowing that it's kind of useless to us. So now, that is the weight in kilograms of one cone. So now, let's find our weight of 50 cones. So if we multiply that number by 50, so I'm going to quickly just divide this by 1,000 in my calculator, and then multiply it by 50, I get 11.6278. So that gives me 11.6278 kilograms as my weight for 50 cones. So now if that's how many 50 cones weigh, and I know what the cost is $3.83 per kilogram. So if I multiply those two together now, so that number times $3.83, I get a total cost of $44. Oops, sorry, wrong one. I get a total cost of $44.53 for our cones. So just to recap, we initially found our total volume by finding the cone and the hemisphere and adding them together. Then we found out the mass of one cone in grams, divided by 1,000 to put it into kilograms. We multiplied it by 50 to get our total volume of 50 cones, or excuse me, our total mass of 50 cones. And then we multiplied it by the cost per kilogram to get what it would cost us to make 50 cones.